Good morning. This is Mrs. Dubois, and I'm going to talk to you about factoring polynomials. All right, if you want to refer to it in the book, it is section 9.4, part 1. And we're talking about factoring polynomials. And the first great rule to factoring is to always look for a GCF. That is now and forever, no matter where you are in your mathematical career. You should always look for the greatest common factor when you are factoring. So I'm going to define greatest common factor as it pertains to a polynomial. And the greatest common factor of a polynomial is a monomial with an integer coefficient that evenly divides into each term. Right? Just to refresh your memory from years past, let's find the GCF of a couple of numerical values. So for example 1, the GCF of 45 and 15, the highest number that evenly divides into both of them is 15. So GCF is 15. For 2, the highest number that goes into 120 and 50 is 10. GCF. For 35 and 47, the highest factor that divides evenly into both of them is 7. All right? And then for the last one, the greatest number that evenly divides into 24 and 51 is 3. All right? And let's just take a little side note and look at the divisibility test for 3. To decide if something is divisible by 3, you add the digits. So 2 plus 4 is 6. All right? So 6 is evenly divisible by 3. Hence, 24 is divisible by 3. And then 5 plus 1 is 6 also, letting you know that 51 is also evenly divisible by 3. Sometimes I think the way 51 looks, a lot of people think it's prime, but in fact, it's 3 times 17. All right, now we're going to move into section 2, which is finding the GCF of a polynomial using the distributive property, or because we're factoring, you might think about it as undistributing, okay? So here are some leading examples. Example 5. If we are given the binomial 2x plus 4, we can pull out a GCF. And the highest factor that evenly divides into 2 and 4 is 2. All right? And I always like to double check my work. So you can double check this by using the distributive property. 2 times x is 2x. And 2 times 2 is 4. So we are on the right track. All right. Example 6. Again, you are looking for the highest factor that evenly divides into 15x and 5. And the highest number that evenly goes into both is 5. All right. And if you're up for it, you can double check yourself. And in fact, this side of the equation does equal this side of the equation. Okay. Example 7, looking for the greatest factor that divides evenly into 45 and 15. Voila, is 15. And again, if you check that back, 15 times 3x is 45x, and 15 times 1 is 15. Right. Moving along to example 8. We have 24x plus 51. So as you can see, I used 51 up the top and 51 at the bottom. And so we know the greatest common factor, or the highest number that can divide evenly into 24x and 51, is 3. Now let's see if you can find the GCF. Okay. If we look at 9, you have 12x and 42y. And so you're looking at 12 and 42, And the greatest number that goes into those is 6, that evenly divides into them is 6. right? Now, in example 10, it gets just a little trickier because we have the same variable raised to a power, all right? So first, let's deal with the numerical values. So you want to look for the GCF of 24 and 4. And the GCF of 24 and 4 is 4. 4 evenly, the highest number that evenly divides into both. Then you want to take a look at x to the 4th and x to the 3rd, all right? And you want to find the highest amount of x's that go into both terms. So if I was going to write it out longhand, this term has 4 x's. I'm going to put the 4 just so you don't get confused. And this term has 3 x's. All right, so I can pull 3 x's out of here, and I can pull 3 x's out of here. So my answer, the greatest common factor, is 4x to the 3rd. We'll try the same philosophy again for example 11. First, all right, you have the binomial 12a to the 5th plus 24a squared. First, we'll look at the greatest common factor for 12 and 24, which is in fact 12. And then we are going to look at what is the highest number of a's I could take out of each term. And if you write it out longhand, it's probably the best way to look at it in the beginning. All right, you can see that I can take 2 a's out of this term, and I can take 2 a's out of this term. So your greatest common factor here would be 12a squared. Okay. For number 12, we now have a trinomial. All right. And remember that this is a 1 in front of there. So 1, 5, negative 5, and 9 don't have, their greatest common factor is 1. So we can't really pull anything out of that. But we are going to take a close look at the variables. And again, this term right here has 3 v's. The middle term has 2 v's, and the last term has 1 v. So you're still thinking, what is the highest number of v's I can pull from each term? And I have to be able to pull that number from each term. So I can pull 1 from here, 1 from here, and 1 from here. So the greatest common factor is v for this trinomial. Now we're going to put the philosophy of finding the greatest common factor and undistributing together, okay? So remember that finding the greatest common factor is the first great rule of factoring. So I'll take the same approach. I'm going to look, what's the greatest common factor between 2 and 26? And it is 2. And then I'm going to examine my variables. What's the highest number of a's I can pull out of both terms? And that is a. So my greatest common factor is 2a. And if we want to double check our work, we can factor this back. We can distribute this backwards. So 2a times a is 2a squared. 2a times 13 is 26. So we would get back the left and the right side of the equation are equal. Okay, move this up a bit. All right, for example 14, this trinomial, we're looking for what's the highest factor that we could put into 12, 4, and 4, and that is 4. And then we're going to see what's the greatest number of s's that I can pull from each term in this trinomial. So the highest number of s's that I can pull out is actually just one s. So the greatest common factor here is 4s. All right, now I'd like you to try it on your own. The directions will say factor, all right? And I specifically told you to factor finding the GCF and undistributing. So you are looking for the greatest common factor that goes into 15, 45, and 30. And that number is 15. And then this has 4 x's, this has 3 x's, but this term does not have any x's. So I cannot pull out a variable or the same number of variables from each term. So the greatest common factor here is just 15, and then you're left with x to the 4th plus 3x to the 3rd minus 2. And as always, you can check back by distributing to see if you get this original equation. And you would if you distributed. All right, 16, I would pause the video. I would try this one and see if you can get it on your own, and then start the video and see what the answer is. So for the coefficients, the greatest common factor is 7. And then as you can see, we have an x's in all 3 terms. So the highest number of x's that I can pull out is x squared. All right. And so now you're thinking, I have 7x squared. What am I going to multiply by that? I'm just going to erase this. What am I going to multiply that by to get 7x to the 6th? Well, I need 4 x's. So my first term inside the parentheses would be x to the 4th minus 7x squared plus 5. All right? And as always, to double check yourself, you can distribute back. 7x squared times x to the 4th is 7x to the 6th. 7x squared times negative 7x squared does in fact give me negative 49x to the 4th. And then 5 times 7x to the 2nd does give me 35x to the 2nd. So we're in the right spot. All right, thank you. Have a good day.